Okay, we're going to find the instantaneous speed of a particle, namely a ball. In physics, it is shown that the height of a ball thrown up with an initial speed of 80 feet per second from a rooftop that is 96 feet high is, let me write down the formula. The formula is going to be S, and the function of S of t equals negative 16t squared plus 80t plus 96. Okay? T is the time, where t is the time elapsed that the ball is in the air. The ball misses the rooftop on its way down and eventually strikes the ground. We're going to answer several questions, 8 questions about this, and you do this in physics usually. So, when does the ball strike the ground? So basically, we want to know when it strikes the ground, that's when S, which is the function of S of t, is 0. So we set our equation to 0. Sorry. And we're going to, this is at time 0. So I'm going to divide everything by 16, or negative 16, and I'm going to get t squared minus 5t minus 6 equals 0, and I'm going to factor, and we're going to get t minus 6 times t plus 1 equals 0, and so we get t equals 6, or t equals negative 1. So basically, we're going to disregard the negative 1 because we can't be in negative time, and the ball strikes the ground after 6 seconds. Okay? Okay? And the next question is, at what time will the ball pass the rooftop on its way down? So basically, what I'm going to do, we already know that it is 96. It's 96 feet. So we're going to set this to 96 feet. And solve for t. So you subtract 96 from both sides. And, well, we can divide everything by 16 at the same time, negative 16. And we'll get t squared minus 5t equals 0. I factor out a t. Basically here, let's just be clear, I subtracted the 96. That leaves 0 here. I divided everything by negative 16, like I did in the previous slide. So we get t times t minus 5 equals 0. So we get t equals 0 or t equals 5. We disregard the solution t equals 0. The ball passes the rooftop on the way down after 5 seconds. Okay. Now, what is the average speed of the ball from when the time is 0 to when the time is 2? So what we're going to do is do the change of s speed over the change in time, and that's going to equal s of 2 minus s of 0, just your slope formula, over 2 minus 0, and that gives you 192 minus 96 over 2. And that's going to be 48 feet per second. And now we want to know what is the instantaneous speed of the ball at time 0. So time 0 is this way. I couldn't do it on the iPad. At time 0. So we're going to take the derivative. We're going to take the derivative of s of t times 0 equals the limit as x approaches, or not x, t approaches time 0 of s of t minus s of t 0 over t minus t 0. Now, this is going to give us the limit as t approaches t 0, and we're going to have negative 16t squared plus 80t plus 96. Then we're going to subtract times 0, which is negative 16t squared, where it's the 0, plus 80 times 0 plus 96. And if you can imagine, I still make another mistake as usual. All over t minus t 0 times 0. Now we're going to factor out the negative 16, collect like terms, and I suggest you do this on a separate sheet because I only have this one slide. I'm going to factor out the negative 16 and then put this together. So we have t squared minus t squared 0 minus 5t plus 5 at times 0. So I just grouped everything together and collected like terms. Alright, and now what I'm going to do is factor by grouping. We have the limit as the time goes to the initial time of negative 16, and this is all over, by the way, t minus t, the initial time. So we're going to factor this out and get t plus t 0 times t minus t 0. I'm factoring this part out. Minus 5 times t minus t 0. Now, let me get a different color. Now I'm going to factor by grouping, and I get negative 16. Again, this is all over t minus times 0. So negative 16 times t plus times 0 minus 5 times t minus times 0 all over t minus times 0. So I'm going to cancel this out. I'm going to finish this up, and when I finish it up and put in t0, so basically I'm plugging this in. I'm going to limit as t approaches the initial time is negative 16 times 2t0, because I'm substituting this t with t0 minus 5 feet per second. So this is the formula you want. Therefore, the instantaneous speed of the ball at time t is this formula. All right, now we want the instantaneous speed of the ball at time 0. So basically, I'm going to write what I had on the previous page, where we found the instantaneous speed of the ball at time t. And at derivative of the speed at time 2, I'm going to plug it in. We get negative 16 times negative 1, and this equals 16 feet per second. Okay, the next question is, the instantaneous speed of the ball is 0 when? So basically I'm setting my equation, my derivative, to 0. So that's Negative 16 times 2t minus 5 equals 0. You solve for t, you get t equals 5 over 2, which equals 2.5 seconds. The next question is the ball, when is the that's not it. What is the instantaneous speed of the ball as it passes the rooftop on the way down? And when t equals 5, we're going to let t equals 5. So we're taking the derivative at t equals 5. And you're going to put it in the formula here. It's 10 minus 5. That equals negative 80 feet per second. So at 5 seconds, the ball is traveling negative feet per second. When the instantaneous rate of change is negative, it means the direction of the object is downward. The ball is traveling 80 feet per second in the downward direction when t equals 5 seconds. Okay. And the next one, what is the instantaneous speed of the ball when it strikes the ground? Okay, that's when t equals 6. That's what we're looking at. So we take the derivative of the speed with respect to 6, and we get negative 16 times 12 minus 5, and that gives us negative 12 feet per second. So the speed of the ball at time 6 seconds is a negative 100 feet per second. Again, the negative value implies the ball is traveling downward. Okay, I have several of these kind of problems. They're very hard to do on the iPad here because of the typing aspect. If you want me to do more, I will. Just shoot me an email or make a comment, and I will do more of these problems.